All right, so let's talk about the tangent line approximation. And so what we know, where we've been so far, is that the slope of the line tangent to a function at a comma f of a is going to be denoted as f prime of a. Now, the equation of this tangent line, the linear function of this tangent line would be y minus f of a equals f prime of a times x minus a. Now, that looks a little scary, but let's just make sure that we can relate it back to something we know. There's a form for a linear equation called point slope form. Y minus y1, there's my y1 value, equals the slope m times x minus x1. So there you have it. This is just a fancy way using function notation to write point slope form. Make sure you understand that before you go any further in this video. Now, this equation here that we just defined up here can be expressed in terms of y explicitly by just bringing f of a over to the other side. So we can say y equals f prime of a, the slope, times x minus a, x minus x1, plus f of a, y1. And so what we know about local linearization, and you've seen this before, that when we zoom in on a graph, the tangent line and the function itself start to look one and the same. They both are very, very linear at very small when we zoom in. And so the point AF of A is also going to be exactly the same point on the line y equals L of x, where L of x is the tangent line. Okay, so now, having said that, here's another way that we can look at this. If we watch this animation, we can see, and again, this is not going to be new to you, you've done this before, that when we zoom in on a point, and we're going to call this a well-behaved graph, smooth and continuous graph. When we zoom in on that blue point here at x equals 1, the red line and the blue function start to take on the exact same behaviors. So what we're going to do with this, that red line, that tangent line is going to be used to help us estimate a value for f of x when we don't even know what the function is. That's coming in a little bit. All right, so we have this equation that represents the slope of the tangent line. Y minus f of a equals f prime of a times x minus a. Again, you don't have to memorize this. This is just y minus y1, the output, equals the slope at that point times x minus x1. And if we add that f of a over to the other side, this is the way that we're going to be writing linear functions. You can forget y equals mx plus b. We're not going to be using y equals mx plus b because in the world of calculus, this is a much easier equation to work with, and you'll be convinced of that later on. So we're going to let L of x, which is the equation of the tangent line to f at some point a, be this function. And what that implies is that the local linearization of f, of the function f, at the point f, at the point a f of a, is going to be the equation of this line right here. And it's perfectly acceptable to say that when values of x are really close to values of a, like within 0.01 or 0.001 or even 0.1, then f of x and L of x are approximately the same thing because they make that line and they kind of lie on top of each other. So that's why we can use L of x to estimate f of x at a certain point. I hope this is making sense. All right, here's a quick example. Let's say f of x has its tangent line approximation given by this equation. L of x equals 3 minus 2 times x minus 1. Okay, now keep in mind that this is just basically point slope form. So the slope of the line is going to be -2. The point that it passes through is going to be 1 comma 3. Make sense of that before you go any further. We want to find an estimated value for x near of f of x for x near 1, such as 1.2. So it's very close to 1. And we're going to use L of x to actually do that because L of x is very similar to f of x. So f of 1.2 is approximately L of 1.2. So when I plug in L of 1.2, I end up getting 3 minus 2 times 1.2, blah, 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 blah. You guys can go through that, and you get 2.6 for your answer. Okay, so what do we have here? We know that if the slope of the tangent line to a function is f of a plus f prime of a times x minus a, which is just point slope form, then it follows that f of x is approximately f of a plus f prime of a times x minus a. Approximately. Because remember, L of x is a tangent line, and when you zoom in and get really close for all x values near that a value, then f of x and L of x are approximations of each other. And that is that.